Please welcome Lea Becker, BMW Foundation, Herbert Quandt.
Last, but certainly not least, we're turning our eye away from the chemical sector to the construction sector. The next company is turning buildings into carbon sinks by using biochar and mixing it into cement. And we had the pleasure of working with them a year ago, and they made amazing progress since then. You can now sit on carbon neutral benches in Potsdam. You can walk on carbon neutral streets. And maybe one day you yourself will live in a home that is a carbon sink. Welcome, Micheil from ecoLocked.
Breaking the wall to scale up carbon removal. Micheil Gordon, ecoLocked.
Hello, everyone. Yes, so when I walked into this building this morning, I thought to myself, I wonder how much concrete has been used to build this very building. And I estimated between 3,000 to 5,000 cubic meters was required, which unfortunately would have released around 1,000 tons of CO2, or the equivalent of 500 return flights from here to New York City. And this is typical of many construction projects. So the problem is that cement contains a huge amount of CO2, which when produced in the calcination process, not only requires a lot of energy, but releases CO2 as well. Now, what we notice is that the construction sector is not slowing down. In fact, it's growing. Over the next 40 years, it's estimated that we will double the number of buildings on our planet, which is the equivalent to building a new Berlin every single month. Now, the emissions that are being released from cement are contributing to the overall greenhouse gas emissions. And you've seen this curve before. Each year, we are saying we're going to reduce emissions, but each year we increase them. And this is true since 2021, about 1.5% increase every single year, which makes getting to net zero by 2050 harder and harder. So all IPCC pathways to net zero now require carbon removal. And that's where ecoLocked comes in. We store atmospheric CO2 in buildings. So, how is this done? We work with a material called biochar, which is a negative emission technology produced from waste biomass residues. And we convert this material into ready-to-go admixtures for the concrete industry. Biochar is a very carbon-rich, stable, charcoal-like material that is produced from effectively waste. The carbon is so stable that provided it's stored safely, can exist for thousands of years. But there's some problems using biochar in the construction industry. Unfortunately, it can be heterogeneous, it can be hard to quality control, and we need that safe storage location for it. And that's why ecoLocked has been working tirelessly for the last 2.5 years in our R&D laboratory, testing these different types of materials. We've tested more than 50 different biochars in more than 600 concrete mix design formulations, and these databases have been put together to develop our product optimization platform and processing hub. Through these tools, we enable the use of these heterogeneous materials for market-ready concrete and construction material products. We have already released our first product line to the market called ecoLocked Materials, which is a range of concrete admixtures that enable our customers to build with fully carbon neutral concrete. And it hasn't been easy. We've built up a laboratory actually just outside Berlin in Bernau, and our R&D team have been tirelessly testing day in, day out to ensure consistency, quality, and performance for our customers. And we're able to store now 200 kilos of CO2 in every cubic meter of concrete, with our vision for 1 gigaton of cumulative CO2 impact by 2040. Our first product, ELM0, is already out in the market, and we have, and it replaces around 10% of other higher emitting concrete ingredients without affecting performance. We have delivered products into applications such as ready-mix concrete, precast pavers, pathways, bricks, and including, as Leah said, benches actually located in Potsdam, just south of Berlin. How is this done? We have our baseline footprint. We reduce the CO2 by replacing the high-emitting ingredients in concrete with our materials. We inset the negative emissions from the biochars, and we achieve 100% climate-neutral concrete. I'm a mechanical engineer and environmental scientist. My two co-founders are both business ex-BCGers, and our full team, we are 21 employees from 30 different nationalities across 4 continents, with 5 PhDs and more than 15 publications. What are we doing next year? We're commissioning our first manufacturing plant. We're reaching 1 million in our revenue. We are achieving 3,000 tons of CO2 impact and working hard to bring down the price premium to 0 by 2026. And of course, last but not least, raising our Series A financing round of 10 million. Thank you.
Perfect. Perfect landing. Okay. Let's go with questions. Last opportunity to ask. David, we're going to start with you today. Now, I mean, sorry. It's the end of the day.
Today or tomorrow?
No, today. Now.
Yeah, thank you. It looks like a great idea, but my understanding is that the concrete industry is already locking in carbon by using pulverized fuel ash for the waste of coal-fired power stations, of which there are millions, probably billions of tons. That's cheap, it's cheerful, it needs to be used. How are you going to get in the market when there's already that supply in there?
Yeah, so fly ash is a great solution. We're not competing with fly ash. Fly ash can bring down the overall emissions of a cubic meter of concrete. If you couple all the technologies readily available now, you can get to around a 50% reduction. So no technology can get to that net zero, and that's where we come in. We can be the technology on top of these to really enable this net zero overall footprint.
Okay, next question here in the first row, and then we will have Stefan.
I would like to ask a question about the consistency of the properties of the material during the production process compared to the existing materials. If you would like to bring into the buildings, it's going to be about the safety and parameters of this material.
Yes, correct. The construction industry is notoriously difficult to enter because of the certification barriers. So we've already started addressing those early on. You'll notice that our first go-to-market products are in the low structural precast segment, and that's where we can grow. In fact, there's a market of 125 billion there. So we're growing in that segment, meanwhile going for certification, where we can then start building or incorporating our materials into structural projects, such as apartments and so on.
Okay, thank you. Next question, Stefan first, please, and then I see you.
I think my question goes a little bit the same direction. I mean, a little bit more precise. What is the load-bearing capacity of your material compared to concrete?
So we have achieved a C30-37, so 37 megapascal concrete with our mixed formulations, and the majority of concrete is between 20 to 37 megapascals. So we really targeted the largest market for structural concrete already. But of course, when we're talking about the lower structural concrete, then it can be used in either less quantities or.
Okay, we still have 2 questions from the audience. Very quick, please, here in the 3rd row, and then we will have this one in the
One question
back.
to the cost. The cement and concrete industry will offer this year or next year already also carbon-free concrete or close to carbon-free concrete. It's all about pricing and cost. What's your targeted cost for your carbon-free concrete in 2026?
Yeah, so at the moment, we're at about a 5 to 20% premium, and we're bringing that down by sourcing lower cost feedstocks for our input materials, improving the performance, so we can actually bring performance benefits and compete with higher, more expensive products that we would replace, such as, for example, pigment. Yeah, that's already a much higher material to replace than, for example, sand or cement or aggregates. And so with these technologies and these higher value replacements, we can bring our costs down. I said we're building our first production facility, so this is where we can affect our cost of goods sold, and we become more efficient. And that way, by 2026, our goal is to be cost neutral.
Great. Last question, very short, please, short answer. We have 30 seconds.
I have many, many questions, so I need to talk to you later. But what is the biomass you're working with? Did you consider low-quality biomass like plastics or manure or sludge?
Sludges we've tested, plastics no, because it's quite low solids and quite high gas. But we've worked with anything from, we're working with, of course, forestry waste, so wood. We're working with agri-wastes, so waste from chocolate factories. We're working with like husks, rice husks, and yeah, so we're definitely considering all of these, but the beauty is that it's localized. So wherever we go, we can find waste biomass, and with our product optimization platform, we can use that material.
Fantastic. Thank you very much.
Thank you.